About 6 years ago, Riley Enterprises incurred $45,000 to increase its store's capacity. Back then, it thought the increase in capacity would increase cash inflows by $6,000. Looking back, though, the company believed the increase in capacity resulted in cash flow increases by $8,000 in each of the last 6 years. The company's desired rate of return is 10%, so what's the net present value actually achieved? And show your work. All right, so let's work through this one. First, let's lay out the cash flows. All right, time zero is today, and we're saying for 6 years, it had a positive cash flow of $8,000 given right there. All right, now I'm going to solve this in two ways. First, using present value of an annuity table approach, and then using Excel. So let me move this out of the way. Well, actually, we'll walk through it. Okay, the interest rate is 10%. That's given. The number of periods is 6. All right, so what we need is to calculate the present value of that $8,000 annuity stream. So we would use the present value of an ordinary annuity. That means we're assuming the payment occurs at the end of the period, not the beginning, where the number of periods is 6, given by the variable n, and the interest rate given by the variable I, and I probably should make that lowercase. Let me do that. Okay, is 10%. Okay, so I'm saying this is the present value of the annuity. Now, how would we come up with that amount? Let me slide this over, put this on the screen here. Okay, so if you look there, using a present value annuity table, which you can find online or in a textbook or in homework manager programs, we want to find the value where we're using the correct interest rate and number of periods. So 6 is the number of periods, and the interest rate is 10%. So there's our value right there, 4.35526. Let me slide that off to the side. We can leave that on the screen if we want. All right, so then what we would do is multiply the annuity stream amount, the payment amount, by the present value of the annuity factor. And when we multiply 8,000 times 4.35526, we get 34,842. That's the present value of the future cash flows. Now, if we subtract out the present value of the cash flow spent today, right? The present value of $1 today is $1. So that 45,000 cash outflow would have to be subtracted, and then we've calculated the net present value of this situation, and it doesn't look good. It looks like this was a loser. Okay, next I've adjusted the screen so we can look at this using how we would solve this with Excel. So let me get rid of this one right here, and we can show you how we solve this using Excel. All right, so we need to calculate the net present value of the future cash flows. And how you would do that is use this function. Okay, now I've adjusted the screen so that you can see the function up top here. So I'm going to hit this insert function button. You see I've worked it ahead of time, but we can just work this from scratch, right? You'd hit the button, and then you'd say, well, what's the rate? Well, the rate is given right there in cell D21. Okay, and then what are the values? Now, they want you to start in period 1, not period 0. Don't make that mistake. Start in the first future period. And we'll just come up here and we'll say these are the values, just to highlight them all. Okay, and that's really all we need. We hit OK, and we get the future values of 34,842. Now, if I get rid of this, what do we see? Then we subtract out the present value today, 45,000, and we see we get essentially the same number off a penny, which doesn't matter because the decision still shows us that this is not a good value. Now, if by chance you wanted to solve all of this in one cell, you could certainly do that. You would say equal NPV, hit the left parenthesis, and go up to the insert function. And by the way, you don't have to do it this way. You could just start typing in the parameters. Maybe I'll demonstrate both here. Okay, the rate is D21, and the values, again, I'm repeating the same steps, would be right here. Okay, now if you hit enter, you're going to get the same value. But if you wanted to do this all in one step, then what you'd have to do is add to the end minus the initial cash flow. All right. Well, we're subtracting the initial cash flow, but since I've entered it as a negative, we need to add it. All right. And as soon as I do that, you'll see it's the same value as the same answer as what we've received before. Now, I want to make one other point. If the cash flows weren't all the same, this simple approach using the table approach wouldn't work. You would then have to calculate a unique present value for each value that's different, that's not part of the stream. So let's assume this was 5,000 in the last year. Okay, at this point, you'll see that NPV will give you a different answer, and it will be the correct answer. And the reason for that is because when it does the future cash flows, it now recognizes that 5,000 is different. So NPV is certainly a powerful function, and it can simplify the work, meaning using Excel's NPV function is probably simpler than using the table approach. All right, I'm going to put that one back to $8,000. And I did capture the image over here. I'll bring that over of what that would look like when you call in the insert function, though I've certainly demonstrated in this video. Okay, and that solves this one, everyone. Thank you.